Hello, this is the daily video for July 13th. Alright, so before I start into what we're going to talk about today, I just want to kind of briefly recap what we've done the last 2 days. And the reason for this is this entire module is really going to build on each other. So whereas the other module 1, the ideas seem kind of disconnect from day to day. They dealt with one another, they all have the same topic. But really, in Module 2, we are building on things from day to day, so keep that in mind. So the very first thing we did was we started talking about 4 very important vocabulary words, and that's the sample, the population, the statistic, and the parameter. So I'm going to, in this video, use a running example, so let me go ahead and set up what that example is. All right, for those of you not on campus, there's a street on campus, it's called Rose Street. Rose Street has been closed, or a portion of it, for quite some time due to construction. Now, the construction that's had that road closed is going to be finishing here in the fall, and there's some debate over whether or not that street's going to be reopened or closed permanently. So suppose I'm interested on the perspective of UK students, and I'm interested in the percentage of UK students that would like to see that road opened back up to car transportation. And so notice in this case, the students or the people that I'm interested in are all UK students, and so that's going to be my population. It's a pretty big population. It would be hard for me to survey everyone. So what I'm going to do is I'm going to take a sample of UK students, and I'm going to ask that sample of UK students, how do you feel about this issue? So I'm going to find out from that sample the percentage that think the road should be open to cars, and that percentage is going to be the statistic. And hopefully I'm going to use that statistic to learn about the parameter, which is the percentage of all UK students that would like to see that street opened. So that's kind of the setup there. Now the next day what we did was you saw ways to take samples. How we take the sample is very important and dictates the type of inference that we can make. So for this example, I'm going to assume that I took a simple random sample of 100 students. And one way to think of how I did this was I called the register. I got a list of all UK students' ID numbers, and then I used a random number generator to help me pick 100 of those IDs, and those are the 100 students that I go and I sample. So let's say I talk to those 100 students, and again, that 100 students is my sample, and I ask those 100 students, all right, how do you feel about Rose Street? Would you like Rose Street to be open to car transportation? And I find that of that 100 students, 53% of them think the road should be open to cars. So in this particular case, 53% is going to be my statistic. Now again, just to iterate, what I'm trying to do is I've only spoken to 100 students, and I asked them, and I found that 53% of that 100 would like to see the road opened. And so that 53% is the statistic. But remember, what I really want to know is I really want to know out of all UK students what percentage want the road open to cars. So the goal is here, I need to find ways to use that 53% to learn about that parameter, that percentage of all students, the thing that I'm interested in. And so today we're going to start talking about how to go about using that statistic to learn about the parameter. Now, one important thing we have to talk about first is what we call sampling variability. Now, hopefully you would agree with me. Let's say I took a second sample. So again, I go to my random number generator, I generate a different 100 student ID numbers, get a different set of 100 students, and I ask them what percentage of you would like to have the road open. And this time I find that it's 60%. So hopefully it seems reasonable that if I speak to a different 100 students, that percentage is probably going to change some. And so that change in the statistic from sample to sample, that's what we call sampling variability. And what you're going to find out today is if we take the samples randomly, so if each of the samples I take is a simple random sample, the statistics are going to exhibit a pattern. And so this is one of the reasons why random sampling is so important. If I take random samples, I'm going to know something about the pattern of statistics that come from random samples. And if I know something about that pattern, then I can use that pattern to tell me how to use the statistic to learn about the parameter. So see how this is starting to get kind of complicated. So this is why it's really important that as we go, you learn those vocabulary words, because it's really going to start to build on itself. So like I said, what you're going to do in the first exercise today is we're going to start looking at the pattern of statistics and where each of these statistics comes from a random sample. So we're going to look at what statistics look like when taken from many samples from the same population. And so that's what the first worksheet's going to do today. And what you're going to find, it's really neat. And so after you do this worksheet, kind of step back and think about it for a second. I can tell you with certainty that, let's say we go back to my example where I took a sample of 100 UK students and I asked the percentage that are going to, that like the road to be opened. If I repeat that process a whole bunch of times, so let's say I take one sample of 100 students, I find a statistic. And I go back and find a second sample of 100 students, find the statistic. And I repeat this process. And let's say I repeat it a whole bunch of times. If each of those statistics that I found, if I plot them, so all I'm going to do is make a histogram of those. Remember we made histograms in Module 1. If I make a histogram of those, if I take enough samples, it is going to be bell-shaped. So it's always going to have this nice bell shape. And that plot is going to peak at where the true parameter is. And this happens every single time. So in the first worksheet, what you're going to see is I've set up an example for you, and it's going to be a special case where you actually know what the value of the parameter is. So remember, we don't know what it is, but in that worksheet, and I'll talk about in the video that goes along with the worksheet, you actually know what the value of the parameter is. You're going to take lots of samples from a population, you're going to plot them. And what you're going to see is that plot that you get is going to be about bell shape and it's going to peak very close to the parameter. Now, one thing to keep in mind in that worksheet, and you might want to come back to this video and watch this portion here again when you go to answer the questions, is you're going to make a plot of 30 statistics. It's not very many. So your plot's probably going to be close to bell shape, but it's not going to be exact. And it's going to peak close to the parameter. It might be a little bit off. And that's because you only looked at 30 statistics. Let's say you increase that and instead I had you make 500 statistics. In that case, you would get a very clear bell shape and it would peak directly above the parameter. So do keep that in mind. I don't want you to sit there and have to calculate, 500 statistics. That's why I only did 30 of them. But at 30, you should start to see that bell shape and that peak is right at the parameter. And again, what I'm talking about should make more sense after you watch the videos and work on the worksheet. So that's why I'm saying it might be good to come back after looking at those and listen to these last couple minutes of this video. And so again, I just want to emphasize our goal for today is we're going to start looking at how to use statistics to tell us about parameters. And in order to do that, we have to know about the behavior of statistics that come from random samples. And so today we're starting to look at that behavior and starting to understand that if you could take lots of samples, what the pattern would look like, and then how we can use that pattern to learn about the parameter. And so that's kind of the overall goal for what you want to be able to do today. So really take your time with today's stuff. We're starting to get into some stuff that's pretty complicated, and it's not complicated computationally, it's complicated conceptually. This concept of using statistics to learn about parameters is a very difficult one, and especially really understanding that even though the statistic is going to change from sample to sample, we can still use that statistic to learn about the parameter if we understand the pattern that lies behind the statistics. So as always, I'm here if you have questions. Please use that discussion board. I would really like to start to see people haven't been using the discussion board very much, but I really want to encourage you to do that because we are going to start getting into more complicated topics. Now, I have included videos that kind of help walk you through this.